Hi, Math 3 students. Today we are going to go over kind of some new stuff, some stuff we've seen before, but maybe in a different kind of light here. So let's go ahead and get started. So for number 1, all right, they want us to find sine of theta. Now, what's going on here is theta is going to be represented by this red angle that they're showing here. I guess on your paper it's gonna be black and white, obviously, but the angle that they're showing. And one very important thing that you will need to know is that when you're referring to coordinates in sine and cosine, well, actually, let's see, does that even, I guess that actually won't even matter in this case. It'll come into play later. But think about where this coordinate comes from, right? We go over 4 and up 3. Does that make sense? So if they're asking about sine of theta, all right, we can go ahead and label our opposite and our hypotenuse. We obviously need our hypotenuse, so we're going to do 3 squared plus 4 squared equals, and we could say like hypotenuse squared, which is going to be 9 plus 16, which will give us 25. So our hypotenuse is going to be 5. All right. So for our sine, it's opposite of hypotenuse, it's going to be 3/5. So that's how something like that works, all right? Now, let's go ahead and try one of these that is in a different quadrant, okay? So if we take a look here, all right, we can go ahead and draw in our triangle here. Now, when we draw in the triangle, we want to draw in our theta in relation to the x-axis here. All right, so we can go ahead and create a triangle just like this. And think about these coordinates, right? We went -√7 this way, and then we went 3 up, okay? You want to make sure that you keep these signs, all right? If your x value is negative or your y value is negative, you want to keep that in mind. All right, and in this case, they're asking for cosine, so we need adjacent over hypotenuse, right? So we have to go ahead and work on finding that. So we're going to do 3 squared plus -√7 squared equals our hypotenuse squared. So that's going to be 9 plus 7 equals our hypotenuse squared, which is going to give us 16. So our hypotenuse is 4. All right. And we want adjacent over hypotenuse. So if we were to label this, we have adjacent, hypotenuse, we're going to get -√7 all over 4. And that would be our answer there. All right. Let's see. So let's go ahead and try, let's do number 4. All right. So we can go ahead and draw in our triangle here. Again, when you draw on your triangle, you're going to use the angle that is created with the x-axis right here, okay? And we've got -7, -7. Now, in this case, we actually do not need to find the hypotenuse because tangent is adjacent over hypotenuse. And if we look, we've got our adjacent. No, it's not. Tangent, hopefully you caught my error, is opposite over adjacent, right? So we have our opposite and our adjacent here. So it's going to be -7 over -7. Which is just 1. All right, so really all we're doing is creating triangles out of these values. All right, let's see, why don't we do one more together? Let's try this guy. So they're asking for cosine of theta. So we're going to go ahead and draw on our triangle. This is our theta. And remember, think about how you created this dot here. We went -7, -√15. So for this one, we do need to use Pythagorean's theorem because we need adjacent, we need hypotenuse. So we're going to do -7 squared plus -√15 squared equals our hypotenuse squared. Now, don't make any calculator errors here. Remember, whenever you square a negative number, it becomes positive. So this is going to become 49 plus 15 equals our hypotenuse squared, and 49 plus 15 is going to be 64. So our hypotenuse here is 8. All right, so if we're trying to find cosine, we do adjacent over hypotenuse. That's going to be -7/8. All right, cool. So hopefully you have a decent sense now of how to do these. All right, so now we're going to go ahead and move on and try and talk about quadrants here, okay? So first off, hopefully you are familiar with the quadrants. We have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. All right, now, when we are measuring angles, all right, we always start from here. This would be like our 0 degree measure. This guy is 90 degrees. This guy is 180 degrees. And this guy is 270 degrees. All right. And positive angles go in this direction. All right. Whoa, what the heck is that? And negative angles go in this direction. All right. So really what they're asking in these chunk of questions here is what quadrant these angles would fall in, okay? So, like if we look at 266, all right, if we think about a quadrant here, we know this is 180, we know this is 270, and this is positive, right? And remember, we're always going to start at our 0 marker. So if we go around in the positive direction, we keep going, and 266 is going to stop right before the 270, right? So this is going to be in quadrant 3. All right, number 18. If we take a look, we've got negative 47. So this is our 0. Now, keep in mind, when it's negative, we would go in the opposite direction. So you could think of this as like negative 90, negative 180, and negative 270. So if we go negative 47, we would stop right about here. That's going to be in quadrant 4. All right. Let's see, what would be a good one here? All right, why don't we try number 22? I think that one's kind of tricky. So this one, again, is negative. All right, so we would do negative 90, negative 180, negative 270. So if we go around in the negative direction, boop, we would end up right here, which is going to get us in quadrant 1. All right, so really you just kind of have to use this as your guide. All right, you do have to memorize this. This is definitely something you want to have memorized, knowing where 90, 180, 270, and then if you go in the negative direction, negative 90, negative 180, negative 270. All right. All right, and let's see, these next ones here. So, again, we are going to be using the idea that this is our 0, 90, 180, and 270, okay? And they're asking us for the measure of each angle, specifically the measure of the arrow, okay? So, we know that from here to here is going to be 270, right? Now, we didn't quite make it to 270. We are 50 degrees away from the 270. So, to find the measure of this angle, we would just do 270 minus 50, because we didn't quite make it to the 270. We're 50 away from the 270, which is going to give us 220. All right. Let's see. Let's look at this next one here. All right. So for this one, first off, you have to pay attention to the direction you have to pay attention to the direction we're going in. Notice how we are going in the opposite direction. So this is going to be a negative angle. All right. And we know that all the way from here to here, we would be going negative 180, right? But we are 100 away from there. So if we're 100 away from there, we're actually just going to be at negative 80, which makes sense, right? If we went negative 80, we're just before the negative 90 there. All right, next one here. So this one, we are going in this direction, so we are going to be a positive angle, right? And we know from here to here is 180. We are 45 away from the 180, so we're going to do 180 minus 45, which gives us 135 degrees. All right, next one here. We went in the positive direction, and we are 65 away from 360. So we can do 360 minus 65, and we get 295 degrees. Ooh, this is a fun one. So this one, we went backwards, right? So this is going to be a negative angle, all right? Now, there's a couple different ways we could think about this. We know that this would be like our negative 270, all right? And then we went 85 more in the negative direction. So you could do negative 270 minus 85. That's one way to do that. Which is going to give us negative 355 degrees, all right? The other way you could kind of think of this is think, well, okay, we know that like this is 90, right? So we are 5 degrees away from being negative 360. Well, what's 5 degrees away from negative 360? Negative 355. So there's really no just like set formula. You kind of just logically have to work your way through these, all right? Let's see, this one here. All right, we went positive direction. We know that this is 270. We went 20 more. So we are at 290 degrees. All right, so basically the big takeaway is you're gonna be using these 0, 90, 180, and 270 as kind of your anchor degrees, and you can use that to kind of help you through there. All right, next thing for today, we've got converting from degrees to radians. So first off, what is degrees and radians? So I know you guys probably remember from Math 2, going on your calculator and going from radian mode to degree mode. Basically, radians and degrees are just different ways to measure angles. All right, so think about it kind of like when you're doing, think about like chemistry, right? You guys remember going from like feet to inches or grams to kilograms. Those are just different ways to measure the same thing, okay? So we know 0, 90 degrees, 180, and 270. Hopefully we starting to feel comfortable with this. Now, what is a radian? Well, basically all the way around a circle is equal to 2 pi radians. Okay, so if we go halfway around a circle, right, we would be at pi. If we go a quarter way around a circle, we're going to be at pi over 2. And then halfway between the pi and 2 pi, we're going to have 3 pi over 2. Basically, the big takeaway is that all the way around a circle is 2 pi, and halfway around a circle is going to be pi. All right, so this is kind of the conversion that we use here, is that pi radians is equal to 180 degrees. This you should have memorized. All right, so basically all we're going to be doing is unit conversions for this section. So if we have 130 degrees, all right, and we are trying to get to radians, we're going to use our unit conversion, that pi radians is equal to 180. You always put what you're trying to we have a degree on top, so we're going to put 180 degrees on bottom so that these guys cancel, all right? And then we know that 180 degrees is equal to pi radians, all right? So the way that we are going to simplify this is we'll have a pi on top, and we have essentially 130 divided by 180. So you can just go to your calculator. I mean, it's going to end up being 13 over 18. But if you don't know how to do that in your head, you could do 130 divided by 180, and then math enter. You get 13/18 pi. So the way that you would write this is 13 pi over 18. All right, let's try another one. So for number 38, all right, hopefully we know this, right? 90 degrees, what is that going to be equal to? Pi over 2 radians. But we're going to actually convert it to make sure we know what we're doing here. So we have 90 degrees times, and we know 180 degrees is equal to pi radians. All right, so we end up with pi on top, 90 divided by 180. Math enter. We get 1 over 2. So that's like 1/2 pi, which you would just write that pi over 2, like that. All right, and that is true, right? That's what we said here. All right, let's try 1 more degrees. Let's do, I don't know, 43. All right, if we have 330 degrees, we've got 180 on the bottom, pi on top. We're going to do 330 divided by, 180. Math, enter, and we get 11 over 6 pi. All right, and that would be our radians. Now, when we're going from radians to degrees, all right, so if we're starting out with radians, we want to put our degrees on top. So we're going to do 180 degrees on top and put our radians on the bottom. So notice how that's different here. When we're starting with degrees, we want to put degrees on the bottom so that the degrees cancel. When we're starting with radians, we want to put radians on the bottom so that the radians cancel. All right, so then we end up with 180 on top and a 6 on the bottom, which just gives us 30 degrees. All right, let's try 49. Again, we're going from radians to degrees. We're going to multiply by 180 degrees over pi radians, cancel, cancel, and we end up with 3 times 180 on top, and then we're going to divide by 4, and we get 135 degrees. All right, let's do one more here. See if you could do this one on your own. All right, if we're trying to go from radians to degrees, we're going to put radians on the bottom, degrees on top, cancel, cancel out our pi's. We're going to get 11 times 180 on top, divided by the 6 on the bottom, and we get 330 degrees. This you want memorized, and you are going to have to memorize what goes on top and what goes on bottom. Basically, just remember, if you're starting with degrees, 180 is going to go on the bottom. If you're starting with radians, the pi is going to go on the bottom. All right?